Hi, Mr. Chu, and you're welcome to my study room. Today's study is a continuation of exponential equations, but we are going to base it mainly on exponential equations that result in quadratic equations. Let's go straight to the lesson. Thank you. Our first question is, solve the equation 3 exponent 2x minus 30 times 3 exponent x plus 81 equals 0. These are the things we need to note about this question. The first thing is that we don't have multiplications and division, or let's say this is subtraction, this is addition. So first of all, those tells us that we cannot use the laws just as raw as they are, since the laws involve multiplication and division. So we cannot use the laws raw here. And the second thing we need to know is that we have 3 exponent 2x here. Then we have 3 exponent x here in the second term. And then the third term is a constant. In situations where we have a term having exponent 2x, another term having only exponent x, and another term having only a constant term, is an indication that we will have a quadratic equation from it. So we just go ahead and rewrite our equation to be 3 exponent x all squared minus 30 times 3 exponent x then plus 81 equals 0. Then we let another variable, let's say m. Let m be equal to 3 exponent x. This only means that wherever we see 3 exponent x, we are going to put m there. Therefore, our equation now becomes m squared minus 30m plus 81 equals 0. So this becomes our normal quadratic equations that we know. And here, taking it in the general quadratic equation formula, our a is 1 because the m squared is standing alone. Its coefficient is 1. And our b is negative 30 and c is 81. Now, the only thing we are doing is that we are going to look for 2 factors of a times c, so that when we add them, we are going to get negative 30, which is our b. But since this question is not about quadratic equations, we are going to use a very shortcut way of solving that can help us to finish early when we are working. So we just write our variable m, then we put it in, we leave space and we put it in parentheses, then another m, because we'll be having 2 factors in parentheses equal to 0. That is not all. Now we get the 2 factors of 1 times 81, which is 81. Then when we add, we will get negative 30. The key thing I want to remind us of here is that since the a times c, 81 is positive, and the b is negative, it means that the 2 factors we are looking for must be negative, because it is only 2 negative factors that when we multiply, we will get positive number, and when we add, we get negative number. I just want you to know that. So these factors will be negative 3 and negative 27. Because 3 times 27 is 81, or negative 3 times negative 27 is positive 81, which is our positive 81, a times c. And then negative 3 plus negative 27 is negative 30, which is our b. So we are just going to fix the two factors here the way they are. So we will have m minus 3, then m minus 27 equal to 0. And we are looking for the value of m. So for the product of two numbers to be 0, it's either the first one is 0 or the second one is 0. So that's just what we are going to do. So that means either m minus 3 is 0 or m minus 27 is 0. That's the only way this can be true. And when we equate each of them, when we make each of them the subject, m will be equal to 3 or m will be equal to 27. Good. But then the main question is requiring us to find the value of x and not the value of m. And also we have introduced our own m just to make it easier for us to solve. So now that we got the value of m, which is easier now, we will bring back our 3 exponent x. So we'll write but m equals 3 exponent x. So that means that wherever we see m, we are going to fix 3 exponent x. And this implies that 3 exponent x will be equal to 3. We are just rewriting this. And as we can see, they have the same basis. So therefore, our x is going to be equal to 1 since the bases are the same. Then we take the second side to this one. We'll write 3 exponent x equal to 27. And we can see whether we can express both sides as the common base. And yes, we can, because 27 is 3 exponent 3. This becomes 3 exponent x equal to 3 exponent 3. And since the bases are the same, it means that our x will be equal to, I wrote 3 exponent x, 3 exponent 3. That means our x will be equal to 3. And our conclusion will be x equals 1 or 3. And that is our answer. Our x equals 1 or 3. We take another question. Our second question says, find the true set of 2 exponent 2x plus 1 minus 9 times 2 exponent x plus 4 equal to 0. This is just like question 1. We have 2x here as the exponent, but only that in this case it is a binomial. We have plus another one again. Then we have 2 exponent x only here, so only x at the exponent. We have a constant term. So this is an indication that our equation will be a quadratic equation. We just go ahead and break it down. Therefore, we are going to have 2 exponent 2x first times 2 exponent 1. Remember law 1 of indices, minus 9 times 2 exponent x plus 4 equal to 0. Good. So this will give us 2 times 2x squared. I just brought these two down as a coefficient and I express this one so that I can have my 2x standing alone. Minus 9 times 2 exponent x plus 4 equals 0. So I am now going to let a variable, let's say n, be equal to 2 exponent x. Our equation now becomes 2n squared minus 9n plus 4 equal to 0, because wherever I see 2 exponent x, I am putting n there. So 2 exponent x here, I have n there. 2 exponent x here, I have n there. Alright. Then we are going to solve this one. We are going to factorize first, then we equate each of the factors to 0. So again, in this case, our a is 2, our b is -9, and our c is 4. So here, we are multiplying a and the c. 2 times 4, which is 8, positive. We are looking for two factors of, so let me write the n down. Equal to 0. So we are looking for two factors of 8. Then when we add, we'll get -9. Again, because of the fact that the product of the factors is +8, and when we add them, we can get -9. It means that both of them must be negative. And I'm sure you agree with me that these factors are -1 and -8. Good. Because when we multiply -1 and -8, we are going to get +8, which is our a times our c. And then when we add -1 and -8, we are going to get -9, which is our b. So we write -1 and then -8. But this one doesn't end here. The first one, it just ended there because our a was 1. But here, our a is not 1. So we are going to divide both sides by our a, only the constant side by our a. So this will be over 2, and this one too over 2. Here, I don't want to write a fraction because 1 over 2 is a fraction. So I'll multiply this one with the 2, which is the denominator, and this one with the 2 to get 2n minus 1 as this factor. Then here, I'll get n minus 4 because a divided by 2 is 4, which is not a fraction, equal to 0. Then for this equation to be true, unless one of them is 0 or is equal to 0, and we don't know which of them, so we equate both of them to 0, to be either 2n minus 1 equal to 0 or n minus 4 equal to 0. We want to make n the subject. So we have 2n equal to 1, and we divide both sides by 2. We are going to get n equals 1 over 2, or n equal to +4. N becomes 1 over 2 or 4. But don't forget, the main question is requiring us to find the value of x and not the value of n. And we brought the n ourselves, so we have to bring back our 2 exponent x so that we can find our x. So you say that therefore, or you say that but n equals 2 exponent x, because we said it here, we will let it be, so we are bringing it back, and that implies that 2 exponent x will be equal to 1 over 2, the first one, and we want to make n 2 the common base. That means 2 exponent n will be equal to 2 exponent -1. Therefore, our n will be equal to -1 since the bases are the same. That is not all. Then we go to, oh, sorry. I said, and this is x, this is x, this is x, this is x, not n. So we are just bringing it back. Therefore, our x is going to be equal to -1. Therefore, our x equals -1. Then we go back to the second one. 2 exponent x is equal to 4. We can express both sides to have the base 2. So 2 exponent x equal to 2 exponent 2. Therefore, x equal to 2. Since the bases are the same, we'll conclude our two sets that x is such that x equals -1 and 2. We take the third example, which will probably be the last example for this study, as find the two sets of the equation 1 over 4 exponent 3x squared plus 1 equals 128 exponent x. Good. Here, we are just going to try to see if we can make this 4 and this 128 to be the same base, or to have the same base. And that is possible because 1 over 4 is 2 squared. The 4 is 2 squared, and the 128 is 2 exponent 7. It means our equation now becomes 1 over 2 squared 1 exponent 3x squared plus 1 equals 2 exponent 7 for the 128 and then x. Good. By one of the laws of indices, this will give us 2 exponent -2 3x squared plus 1. Remember that this parenthesis is very necessary because if you don't bring it, the -2 will multiply only the 3x squared and not both of them. But here it is both of them that is the exponent of this. So anything you do to the inside, it must affect both of them so that your answers don't differ. And that will give us 2 exponent 7x. Here the bases are the same, so we equate the exponent and we will get -2 3x squared plus 1 or to be equal to 7x because the bases are the same. We expand the left hand side to get -6x squared minus 2 equals 7x. We regroup all of them to the left hand side. We are going to get -6x squared minus 7x, because when this one comes, we become negative, then minus 2 equals 0. I am not comfortable with negative here, negative here, negative here, especially negative with the first term, which is the x squared terms. So I am going to do this by -1 then that is going to be over -1 over -1 over -1, even here over -1, and this one will give me 6x squared plus 7x plus 2 equals 0. And we are going to factorize because we have our quadratic equation the way we want it now. So we are going to factorize. And to factorize, we are going to try our shortcut again. But don't worry if you are not getting the shortcut. Just use the long factorization method. But here, because our attention is not on factorization, that is why we use that just to get the factors and work. So I bring my x, which is the variable, this way, equal to 0. So our a is 6, our c is 2. 8 times 6 is 6 times 2, which is 12. We are looking for two factors of 12. Then when we add, it will give us the 7 here. And that is 3 and 4. Because 3 times 4 will give us 12, which is our A times our C. And 3 plus 4 will give us 7, which is our B. Therefore, I will just put my 3 here plus 3 here. Then I'll put my plus 4 here. Those become our two factors. But remember, this is just like the example 2 that we solved. Our A is not 1. So we don't leave it like this. We have to divide through the terms, the constant terms by the A. So this over 6, this over 6. And this will give us x plus 1/2. Then x plus 2 go here 2 and go here 3. So 2/3. There's no problem with this. You can equate each of these to 0, or you multiply through here by 2. You get 2x plus 1 and then 3x plus 2. But here we don't even need to do that since we are looking for the value of x. So since the two of them multiply to give us 0, it's either the first one is 0 or the second one is 0. So we say that x plus 1/2 equals 0, or x plus 2/3 equals 0. And that will be x equals -1/2 or -2/3. We have to find the truth set. So our truth set becomes x is such that x equals -1/2 or -2/3. That is it, our lesson for the day, and I hope you enjoyed it. Don't hesitate to give a comment. But more importantly, please like, share with your friends, and subscribe to this channel for more videos like this. And as usual, there'll be questions here after here, so that you take your time, you pause the video, work them out, and feel free to share your answers with me in the comment box. Thank you for making time with me, and see you again next time. Bye bye.